Hello everyone. Alright, today is part 2 of trigonometry. Things are getting a little bit more exciting because now we move on to the real deal of trigonometry problem. So trigonometry in part 1, I've explained about ASTC, I explained about all the different simpler identity. Identity meaning to say that they are the same thing. So we can say that A is equal to B, so they are identical. Right, so in the case of trigonometry, that really helps us to convert the function from one to another. And at the end of the day, what we want to do is that because in our calculator, the limitation is actually that the sine, cosine, and tangent is the three functions that we use. So when you want to find angle or even length to solve anything at all, you will find that most of the time we change it back to sine, cosine, and tangent. So what about today's video? Okay, so today's video, we're going to dive into the deeper problem, which for those equations that's even more complicated, that involve square or even cube in the trigonometry function itself. So in the previous video, you noticed that the last part, when we talk about the equation solving, there wasn't really any need to do square rooting, factorization, and whatnot. But in today's video, because we're going to use the trigonometry identity, so you must actually remember this following key basic in equation solving. So number one is that, not too sure whether you know, you can factorize a trigonometry function. Alright, so in this case, imagine the question started with 2 sine x cos x equals to sine x. Some of you might think, oh, this is a double angle formula. Okay, we're going to talk about it later, but this is actually not double angle yet. Right, but what is this? This is factorization. Or even some of you might be thinking of it this way. Maybe can I just cancel away the term, like I have a sine x on the, hang on, I got a sine x on the right side. This one, I can cancel with the left side. Possibly I can do that. So in this case, then I will just be left with 2 cos x equals to 1. No, that is wrong. Okay, remember cancellation, especially for equation solving, you do this, you will end up be removing some answers. So don't do that. So as a result of that, right, we bring the sine x to the left side, and then we perform an action called factorization. So this 2 sine x cos x is actually the same as 2 times sine x times cos x. Is essentially the same thing. Which also means to say that, right, if that's the case, if we can do that for factorization for the x squared one, we can definitely do for this. Like for instance, 2x squared minus x is equal to 0. I can possibly take out the x, then I'll get 2x minus 1 equal to 0. So for the same reason, trigonometry, we can also do that. So just that you factorize the entire function outside, not just the x itself. So after doing that, right, then once again, you can look at the next step. You find that, yeah, this is exactly what I would do in normal algebra as well, which means to say that x is equal to 0, 2x minus 1 equal to 0, right? I can actually continue from there to solve the equation. And this is exactly what I'm going to do for trigonometry as well. So this is, I would say, common thing to remember, number one. Common thing to remember, number two, the second basic will be, right, you can also do a substitution. So which means to say that sine square x minus sine x plus 6 is equal to 0. So now if you find this very confusing, why not you let y be sine x? Okay, so in actual fact, take note that this is actually sine x times sine x. This is the meaning of sine square x. So if I change it to y, it will just be y times y, which is y squared. So y squared minus y plus 6 equals to 0. So this equation can then be factorized, use your calculator to solve. Okay, so this is basic number 2. So basic number 1, you can actually factorize. Basic number 2, okay, this is a quadratic equation, right? Think of it that way. So this is a quadratic equation in terms of trigonometry. Okay, coming to the page where you find the most familiar, actually for the Sec 4s. Sec 3, maybe you have not looked at this page yet. This is the extraction from the A-Math formula sheet that you'll be given in the exam itself. So these things that you see here, the formulae, you don't have to memorize at all. They will be provided. Apart from the many things that you need to memorize, these are the things that you don't need to memorize. You basically can just take from the formula sheet itself. So starting off from this part, this is the Pythagorean identity. Then the second one is addition formula, this part. Then after that, this is the double angle. Alright, so all these are provided in the formula sheet. I will always say that when you are doing your practices, maybe take some effort to look at your formula sheet to know what is there. So when you are doing it, right, you will know that, okay, this is not given, I better memorize it. Okay, this is given, I actually don't have to memorize it, but I better know how to use it. Alright, so this is the thing that's important to you. And moving on to the actual equation solving now. So I would say that trigonometry, by and large, almost 90% of the time, right, you do a lot of equation solving. Sometimes you do some, I would say, maybe the graphs can change and whatnot, but you do equation more than anything at all. So that's why knowing what to do, the sequence of steps, I have all these steps already inbuilt in my mind. But for you, if you are learning it, then at this point, you might want to try to get this into your brain so that whenever you want to use, you know that, oh, step 1 is this, step 2 is this. So in a very systematic manner. So step 1 will be, right, you must choose the correct trigonometry identity first. Which one do I use? Do I use the Pythagorean identities? Do I use the addition formula? Do I use the double angle formula? So on and so forth. So later I will show you some example of how to identify them. After which, right, you manipulate the equation to the one that you can factorize. Alright? If you are going to do these 3 formula that I just showed you just now, then you will always expect that you will need to do a bit of factorization. Then the last step, 3 and 4, is the same as our video number 1. Okay, video number 1 where we try to solve the trigonometry equations. Okay, the first one, Pythagorean identity. So because you can look at it, right, sine square plus cos square equals to 1, it looks very similar to our Pythagoras theorem because 1 is 1 square. Then 1 plus tangent square, secant square is also 1 is 1 square as well, and so on and so forth. So the use of this identity, right, I would say is to help you to convert sine to cosine, right? If you're talking about the one with no square, then cannot. But now if square, then actually there's a way to do it. In fact, if you look at the first one, can you see that this actually can be re-expressed as sine square x is equals to 1 minus cos square x? Can you see that? Yeah. So which means to say the next time if you see a sine square x in your equation and you think you need to change it, right? Because I don't change it, I'm stuck, I cannot solve already, right? So that's why this will help you to change all the sine square to cos square. Okay, and this is important because in equation solving, you must make sure that all of them is as identical as they are. Like in this example that I showed you here, right? 2 cos square x minus sine x equals to 2. No way to solve it until you change your cos square to sine square. So you change your cos square to 1 minus sine square, and as you continue, then you got the equation is just in terms of sine. And why we need to do that? This is where we can factorize. Okay, so not only the function is the same, this is also the same. Cannot have 2x, x, okay. 2x, x cannot solve already. So the thing must be totally identical. Then from here, you can factorize the solve. And why did I choose to change my cos square to sine square? Just now, didn't I say that you can also do changing of cos square to, sine square to cos square, like in this case? Sine square to cos square. Yeah. So, as mentioned, remember, you can only do this if this one here is a sine square x. Sine x cannot. Okay, sine x you cannot change at all, so you are stuck again. And for the rest, it's also the same. I can change between tangent square and secant square. I can change between cotangent square and cosecant square. All these are useful in helping you to do equation solving. And only look for the one with square to change. Okay, let's look at this question now. You are asked to solve the following equation. 1 minus 2 cotangent square x equals to 5 over sine x. Okay, so how do we do that? Going back to the previous page, I think probably we need to use this. Possibly, right, let's try. So I'm going to use 1 plus cotangent square x equals to cosecant square x. So you start with it first. Make cotangent square the subject. So cotangent square x is equals to cosecant square x minus 1. Okay, then now let's plug it in. 1 minus 2 cosecant square x minus 1, okay, plus 5 over sine x. Then now you will say, sure, I'm stuck. You are not stuck. Actually, we can still continue. Okay, why? Because you need to know that 5 over sine x is in fact 5 cosecant x. This is the memorizing part. The don't need to memorize one is the square one. Okay, the Pythagorean theorem. So now actually we're going to put it in. We get 1 minus 2 cosecant square x minus 1. Okay. Okay, this one is equal, sorry. This is equal. So equals to 5 cosecant x. Okay, 5 cosecant x. So now I bring everything to one side. I will get minus 2 cosecant square x, then plus 1 plus 2 minus 5 cosecant x equals to 0. Okay, if you simplify a bit, you will get minus 2 cosecant square x minus 5 cosecant x plus 3 equals to 0. So this becomes your quadratic equation. Cannot see, right? Okay, let's do this. Y equals to cosecant x. Then we get minus 2y squared minus 5y plus 3 equals to 0. Now can you see? Okay, but remember to put it back. We are solving for x, not solving for y. So after that, you find your y. Then you change it back to y equals to cosecant x. And then after that, you solve for your x. Okay, so for today's lesson, I won't be solving all the way to the end, but I just want to show you how to turn the equation into one that is solvable. And this is by using the Pythagorean identity. And how do you continue from there? Okay, moving on to the next part. Now, I'm going to show you how to prove using Pythagorean identity. Why I chose this question? Because later on, you will see that the identity will be used somewhere down the line. Okay, so remember, proving, right? You need to start from the left or the right, and the part that you start with must be the part that is having more term. So right now, I'm going to start from the left side, because more term, you can reduce it later on. So left-hand side will be 1 plus sine x over cosine x plus cosine x over 1 plus sine x. Okay, so from here, you can see that I have to simplify it. So for fraction, the only way to simplify it will be combine. Okay, put them together. So I'm going to combine it now. Then I'll get 1 plus sine x bracket square plus cosine square x whole thing divided by cosine x 1 plus sine x. So what did I do here? I basically multiplied by 1 plus sine x top and bottom for the left side. And I multiply by cosine x top and bottom on the right side. So I will get the same denominator, cos x bracket 1 plus sine x. Then from here, I can see that, okay, now it's getting a bit simpler. Let me expand the first bracket. So I'll get 1 plus 2 sine x plus sine square x plus cos square x over cos x 1 plus sine x. Okay, then, okay, finally, the Pythagorean identity. Can you see there's a sine square plus cos square here? Change it to 1. Okay, let me go back here again. Sine square x plus cos square x is 1. So change it to 1 now. So this entire thing will be 1 plus 2 sine x plus 1 over cos x 1 plus sine x. Like that, can you see? So now, if I'm going to add them together, 1 plus 1 is 2. Okay, so 2 plus 2 sine x over cos x 1 plus sine x now. Okay, let me go up to the top. So I'm going to get 2 plus 2 sine x over cos x 1 plus sine x. Then how to continue from here? Okay, factorize. So I'm going to take out the 2. 1 plus sine x over cos x, 1 plus sine x. Then now I can remove the 1 plus sine x. I'll get 2 over cosine x, and then this will become 2 secant x, which is equal to right hand side. Yeah. So how do I do so fast? It's because that I remember all my identity well. So the basic one, like what is cosecant, what is secant, you need to be very familiar. And of course, you need to be very sharp. When I see sine square plus cos square, straight away change it to 1. So this idea of proving is that reduce the left-hand side as much as possible. Right? Okay? And a good proving should not exceed 7 steps. If you find that you are doing 10, 14 steps, quite sure you are wrong. You probably is beating around the bush, you are going around in circles. Okay, so this is where you need to take a step back and reevaluate again. Okay, next one, double angle formula. So what do we use double angle formula for? So cos 2 theta is a good thing because in integration, we really use this a lot. This is meant for integration, can be very important. Because integration, I cannot integrate the square one. I can only integrate the one with 2 theta, so no square. Right? So I'm going to use this for integration. For Sec 4, you will know what I mean. For the Sec 3, okay, no worries, you will learn it eventually next year. Then sin 2 theta is 2 sin theta cos theta, and tangent 2 theta is 2 tangent theta over 1 minus tangent square theta. Okay, so these are the equations that you will be using to help you to change between the 2 theta and the theta. So at the end of the day, right, you must make sure that you convert everything to a single theta function so that everybody align. If everything is 2 theta, then okay, but if there's a mixture of 2 theta and 1 theta, right, then you have to change it first. So cos 2x minus cos x minus 3 is equal to 0. So I'm going to change this to 2 cosine square x minus 1. I'm not going to do this. Why do I want to create the sine square? I don't want to. I want to create everything cosine square. So my last step is to solve for my cosine. Right? Because everything is in cosine, then I can factorize. Okay? Okay, let's look at the problem now. So 4 cosine 2x is equal to 3 minus 2 sine x. And if you were following, because cosine 2 theta, there's 3 forms. The one with the mixture of cosine and sine, the one with just cosine, or the one with just sine. Normally, the first one is used when you want to change the cos square minus sine square to reduce to cos 2 theta. But quite seldom we want to open up. Okay, not say we cannot, we can, but we don't really get to use that a lot. But the second one, which is this one, and this one, this is number 1. So 2 and 3 is quite commonly we use them in the equation solving. So like in this question. So for this question, I'm going to use the third one, 1 minus 2 sine square. Okay, so I'm going to use that. So I'm going to change it to 1 minus 2 sine square equals to 3 minus 2 sine x. Okay, something like that. Then I'm going to expand. I'm going to get 4 minus 8 sine square equals to 3 minus 2 sine x. Right, so now you can see it's a perfect quadratic equation in sine. Then I'm going to move the terms in such a way that I will move everything to one side. So 4 minus 8 sine square x minus 3 plus 2 sine x equals to 0. So minus 8 sine square x plus 2 sine x plus 1 is equal to 0. Okay, take note that although I usually, as I do when I do here, right, you usually see that I don't change my coefficient of sine square to positive, right? But I think that is useful, right? Don't leave it in negative, although you can use a calculator. So normally I will make everything positive. I'll make my sine square positive. That's normally what I will do. So this is what I will do, but it's an option. If you want to do it, you can. If you don't want to do it, you can also do it. You can also not do it. Okay? So x sine square x minus 2 sine x minus 1 is equal to 0. This you can solve already. And how to continue? This is a factorization. Okay? You can, like maybe if you cannot see, you can say let y be equals to sine x. So y squared minus 2y minus 1 is equal to 0. Then you solve from here. Then after that, you put your y back as sine x, solve for x from there. Okay? So for the last part where you need to solve the equation, right? How to use the ASTC, I'll suggest you go back to my video number 1 where I've already explained that already. Okay? Okay, next, how to use this to do proving now. Sin 2x plus cos 2x plus 1 over sin x plus cos x equals to 2 cos x. Okay, so now I'm actually going to change my sin 2x and cos 2x now, which is 2 sin x cosine x. Okay, then for the cos 2x, right, I'm going to do this. I'm going to use plus 2 cosine square x minus 1 plus 1 whole thing divided by sin x plus cos x. Okay, then after which, okay, so this is starting from the left hand side. So 2 sin x cosine x plus 2 cosine square x over sin x plus cos x, something like that. Right? So you can see that now the equation is getting simpler. Just now, if you take a step back, why I use 2 cos square x minus 1, not other form, is because if you have realized, minus 1 plus 1 is 0. I will remove the 1 totally. The objective of any proving is to reduce the number of terms as you go along. If you're getting more terms, you should be wrong. So I'm reducing a term. So next, I want to get into a non-fraction scenario. Can I? Yes. Let's think of a way to remove the denominator. So in the next step, I'm going to do this. Then you notice that, oh, okay, after factorizing, right, then now the sin x and the cos x can be removed. And then you are left with 2 cos x, which is equals to right hand side. Done. Just like this. Okay? So this is using Trigo double angle formula to do a proving. And once again, you can see it's only a 3-step thing. If you never think about it, right, you never see a 2x, never use double angle formula, you probably might take longer. Okay, last one, the addition formula. Addition formula is commonly used when you have a sine, cosine with a bracket, and this bracket you have 2 terms in it, right? So an example will be this. Imagine you have cosine pi over 2, pi over 3 minus x, plus sine pi over 2 plus x. So if you use the addition formula now, you could further simplify it into the following on the left side, on the right side, sorry. So in this case, then you can press your calculator, but actually if you press your calculator, it's not a good thing because then you will get non-exact answers. So for here, right, you must remember that pi over 3 is really 180 over 3, which is equal to 60 degrees. Then pi over 2 is 180 over 2, which is equal to 90 degrees. Alright, something like that. So from here, if you remember your special angle, right, then you will be able to change it to this thing. And last thing is that simplify this. So from here, you can combine the half and the 1. So this next step will be 3 over 2 cosine x plus square root 3 over 2 sine x. So this is what you can do. After you have used the addition formula to expand, before that, you cannot combine. After that, you can combine already because the number, the cosine pi over 3 or the sine pi over 2, right, these are the coefficient of the trigo function. So if you use your special angle, you can change them to number and then they can be further simplified from there. Okay, so that's why I say addition formula help you to simplify. And this is our last question for today. Okay, let's take a look. So this is back to the known trigo equation, known trigo ratio thing that we have done before. So let's decide which quadrant to use first. So sine A is 4 over 5, so it's either the first or second quadrant, right? But however, I cannot take the first one since cosine is negative. So meaning to say that, right, if I draw, this will be my A, and if I draw, this will be my B. Okay, we draw them separately. So let's put down the number now. This is 5, this is 4, then I think this is 3. Square root 5 square minus 4 square, you will get 9, square root will be 3. Okay, this is minus 3, actually in fact, minus 3. Okay, because remember, on the left hand side of the y-axis is negative. Then the bottom one will be cosine, right? So this is minus 12, this is 13. Okay, the last one, let me use my calculator. 13 square minus 12 square, square root, okay, this is 5. So this is positive. Above the x-axis is positive. To the left of the y-axis is negative. Alright, so now we are ready to start. Part 1 asks me to find cosine A plus B. So cosine A plus B will be cosine A cosine B, okay, we use the formula, minus sine A sine B. So for me, I already remember that for cosine, right, the first two expression, right, will have the same function. So cos, cos, sine, sine. I remember that already. And I remember that if it's a plus inside, then I will have a minus outside. That's why I read this. Then from here, I can actually put in my cos A now. We look at the first diagram. Cosine A will actually be minus 3 over 5. Then what about cosine B? Cosine B is the bottom, which I already have, minus 12 over 13. Then the next one, my sine A is in fact, we look at the top again, 4 out of 5. Then sine B will be at the bottom, so this will be 5 out of 13. Press your calculator, you get the answer. Okay? So part 2, also the same thing. Part 2 is just we use the addition formula for tangent. Okay, so part 2, so this is part 1. Tangent A minus B, okay, I couldn't remember, let me look at it. Tangent A minus will be tangent A minus tangent B over, 1 plus tangent A tangent B. Okay, for some of you might notice that how I know the sign, right? You look at this, okay, you follow it. If it's the plus, then I will take the plus and the minus. So you follow the sign at the top. But if it's a minus, that's why there's a plus minus, right? If you're minus, then it will be minus at the top and then plus at the bottom. Okay, so that's how I got it. And then last but not least, you just sub in everything that you know. Tangent A would be 4 out of negative 3. Minus tangent B is 5 out of negative 12. Whole thing divided by 1 plus, okay, tangent A once again is 4 out of negative 3. Then multiplied to 5 out of negative 12. Sorry, a bit no space, I move up. And press your calculator, that's all. Okay? So this will be our last example. It's already 30 minutes. Yeah, I hope you have watched till the end. Yeah, so a lot of things to talk about. And I'm just giving you some example of how all of this trigonometry identity is being used. I really suppose that you need to try yourself as well. So this example is to help you to relate and think. If I see the Pythagorean, which one do I use? If I see the double angle, when do I use it? So on and so forth. So you must be able to make the linkages. Otherwise, you will take really too long to do your trigo question in the exam, right? You will never be able to finish, right? But of course, going back to lesson 1 in our first video, that was also the thing that you need to know. Quite a number of things, like the basic identity, your special angle, okay, how to solve the equation, are you able to understand and remember? If not, then I will say go back to video 1, okay, try some question in a textbook, and then before you proceed to video 2. Yeah. There's one more formula that I'm not talking about here, which is the R formula, but I think we can leave that for the next video. Okay, so with that, that will be the end of today's video, 30 minutes, okay, just nice. Okay, hope you can watch until the end. If not, at least you can skip through the different part. So let's say you are weaker in the double angle, look at that first. You are weaker in the Pythagorean identity, right, look at that first. But at the end of the day, right, to do well in the A-math paper, you really need to be very good in your trigonometry. Okay, I will see you again in the next video. If you like today's video, please help me to like and subscribe. Thank you.